layer. As usually before we use like ReLU layer. In this also we used to do with ReLU layer with max pooling layer. So we need to create second convention layer and then extract features and get the results of output, and that is dot product of input into weight. As we discussed about last convention layer, we need to take the size shape like 5 into 5 and input channels of 32 and output channels. Return the output of the layer. I create ReLU layers for second convention and accept the output from first convention as inputs. Perform a computation and return the outputs of layer. So when we perform on it, so we can get the layer. After creating a second pooling layer, we need to reduce partial size as we have done in first convention layer. After creating first pooling layer, we need to reduce the partial size, and, and before that we need to perform a computation and return the output of the layer like first convention one, and then reshape and flatten the output of second pooling layer, preparing to feed the output into first fully connected layer. So we need to keep the second pooling layer into the first one to reshape with this all. Create second convention layer, ReLU layer, max pooling. With that layer, you can get the code of convention layer to output, create convention layer and compute dot product like filter shape equal to 53364. Convention ReLU layer to outputs, create a ReLU layer and compute dot product layers. Convention layer 2 output filter should be like 55364. Pooling layer 2 outputs, create max pooling 2 and reduce partial size. Pooling layer 2 output, class reshape. Pooling layer 2 outputs are like -1, 7, 7, 64. It should be like 4 numbers. Reshaping and flattening the output of the second pooling layer. In second pooling layer, you will get the outputs of 0, 22, 2, 3 and -1, 5, 5, 64. With that, when we expand the shape so that you will get like d type equal to float. So after creating the second convention layer, create first FC layer, ReLU layer and outputting data to dropout layer. And now create the FC layer, feeding the output. Already flattened up the second pooling layer as the inputs in this layer. Performing the computation dot product plus bias x into w plus b With this, the parameters are pooling layer 2 output flat, output size 10, 24 out channels. Then we need to return the outputs of the computation xw plus b. And now create the ReLU layer of the first FC layer. The activation of the function is also ReU. And now return the outputs of the layer to declare a placeholder to hold the value of probability percentage to keep the percentage of the total output channels that will be kept, which nodes are channels we used to say like to keep or drop out selected randomly. um, with this to by creating first FC layer with LU layer and output data to dropout layer. So you will get like FC layer first output equal to create fully connected layer and compute dot product plus bias. Pooling layer 2 output flat, output size equal to 1024. SC ReLU layer 1 output equal to TF and ReLU. Whole problem equal to TF placeholder folder FC dot dropout outputs TF FC ReLU layer 1 output layer key prob equal to hold prob. So by creating first FC layer and outputting data to dropout layer, you will get this code. And now finally we need to create final FC layer. Create the final FC layer, computing final FC layer, computing x w plus b, the parameter FC dropouts, output from dropout layer. Now we need to return YPT, final prediction output, and the final classification outputs. Define loss function like cross scripty with logit with final outputs, and then calculating the softmax cross scripty loss. By using this loss function, um, we need to compute the mean of losses, creating an optimizer to optimize CNN model and set learning rate, get an Adam optimizer by after doing the computing in